it's Gabrielle, and this video is a sample from StudyClix Boost, our new rapid revision tool. Go to studyclix.ie/boost to find out more.
Howdy folks, it's Stephen here with StudyClix, and here we're going to look at using the trig identities to find missing sides in a triangle. So you can see in the question I'm asked to find the length of the side marked with a letter, correct to one decimal place where necessary. Now we have a right angle triangle with sides of length √3x and an angle of 60 degrees in there. Now typically we try to use Pythagoras to find sides of a right angle triangle. However, I don't have a third other side to help us do that. So what I'm going to have to do here is revert to the trig identities. So what I'll do first is state the formulas for each. So for sine, cos and tan, I'm going with SOHCAHTOA, so sine theta equals opposite over hypotenuse, cos theta for K is adjacent over hypotenuse, and TOA, tan theta, equals O over A. So I'll have these sitting ready to go. In my first triangle, in order to find that side x, what we're going to do is first label the sides we have. We know that √3 is the hypotenuse, so I'm calling that h, and x is the side opposite my angle in question, so that's the opposite side O. So what I do here is I look to my formulas and see that I have the opposite in the hypotenuse. Which trig ratio involves O and h? Well, it's going to be sine. So I plug numbers into the sine trig ratio. So it's going to be sine theta. So my sine of my angle is 60, because that's the angle in question. And that equals the opposite side, x over the hypotenuse √3. So the first and hard part is to sub into the formula. Then what I want to do is solve for x from here. So what I'm going to do is get rid of the fraction of √3. I'm going to multiply √3 on both sides. On the right hand side, √3 divided by √3 is 1. So I'm going to be left with √3 sine 60 equals x. And then I'm simply going to type √3 sine 60 into the calculator and get that x here equals 1.5. So you can see what we did is we subbed into the formula and then we simply solve from there. On to my next scenario. I have an angle of 30, a side of 4 and another side of length y. So what I'm going to do first is label my triangle. I'm going to note that the side of length y is the opposite side because it's opposite my angle of 30. And I don't have the hypotenuse here, so that means 4 is the adjacent side. It's adjacent to the right angle. So now I'm dealing with the side O and A, the opposite and the adjacent, and I'm going to look through the formulas and see which one deals with O and A. Well, that's going to be tan theta equals opposite over adjacent. So what I do is I sub into the formula tan theta, so my angle here is 30, so it's tan 30, equals the opposite side y over the adjacent side 4. And now what I want to do from here is simply solve for y, so I need to get rid of the fraction, so I'm going to multiply both sides by 4. And when I multiply the right by 4, the fraction's gone. So I'm going to be left with 4 tan 30 equals y. And I'm going to whack this into my calculator and I'm going to change it to a decimal and round it to one decimal place to get 2.3. Again, all we have to do is label our triangle and choose our correct formula to use. And now let's look at the third scenario. I'm given an angle of 35 degrees in the right angle triangle and sides of length 5 and z. So let's go ahead and label our triangle first. So I'm going to note that z is the hypotenuse because it's the longest side across from the right angle. I don't have the opposite side, so that means 5 is the adjacent side. So now I'm dealing with A and H. So which of the trig ratios deals with A and H? Well, that's cos theta. So I'm going to go ahead and sub into cos. I get cos theta, so it's cos 35 equals A, which is 5, over the hypotenuse z. And now I want to solve for z here, and z is at the bottom of the fraction on the right hand side. So what I'm going to do is multiply both sides by z to get rid of the fraction. So on the right, the fraction's gone, and I'm going to be left with z cos 35 equals 5. And now I want to get z on its own from here, so I need to get rid of the cos 35, which is multiplying it. So I'm going to divide the left by cos 35, which means I must divide the right by cos 35. So then I get z equals 5 divided by cos 35, and I'm going to whack that into my calculator, and looking at it to one decimal place, I'll read off 6.1. And that's the busier case, that third scenario, whenever our variable is on the denominator of the fraction. We just have a little bit more rearranging and solving to do, but there's nothing too dramatic going on. So folks, that's all there is to it. What I need you doing is labeling your triangle every time with the sides you have and the side you're looking for. And then you look to your trig ratios and see, okay, which formula am I going to use here? You choose the correct ratio, sub into the formula, and you'll have a little bit of solving to do. The first two were fairly straightforward for solving, but that third case when your variable's on the denominator is just a little busier. Now folks, it's your turn to practice some of these questions. Pause the video here and check in with the solutions when they appear on screen. For the first two triangles in question 1, we simply labelled a triangle and selected the correct formula and solved. And there we have the third triangle in question 1, again just labelling our triangle and selecting the correct formula. In question 2 here we've a busier scenario, so what I did first was take the rightmost triangle, as that only had one unknown. I labelled it and found a value for x. Then I subbed this value of x back into the diagram, which led me to be able to find y in the leftmost triangle. I simply labelled that triangle and found y using sign. And there you have it folks. Thanks for watching.